Hello friends, here in this video we are going to see a problem on pentagonal prism. Here is a question. A pentagonal prism with side of base 30 mm, axis length 60 mm has one of its corners of base in the HP such that the base of the prism makes an angle of 50 degree with HP. Draw its projections. So just by reading the question, it was understood that the type of solid is a prism, and that too it is a pentagonal prism. Next, it was given that it is resting on one of its corners of base in the HP and making an angle of, that is the base is making an angle of 50 degree with HP. Now if it is making an angle with HP, that angle will be seen in VP. That is, if the inclination is given with respect to HP, it will be seen in VP, or in other words, if the inclination is given with respect to VP, it will be seen in HP. So first I'll just draw the rough diagram of a pentagonal prism and explain it, that what is the initial condition for this problem. Now, here is the diagram of a pentagonal prism. It is having a pentagon at the top and it will be having the pentagon even at the bottom. Next, here I need to understand that how the initial condition would be. Pentagon can be drawn in two different ways. First, I can say that when we are looking from the top view, the pentagon will be Now, a pentagon can be drawn in two different ways. That is, when we are looking the prism, pentagonal prism from top, we are going to get a pentagon, and here in this condition, the first condition which I have drawn, in this case, here I'll say this is an edge AB. It means the pentagon is resting on its edge in this case. But if I look at the second diagram, that is the second condition, here the pentagon is resting on one of its corners. I'll say that the corner is point A. Now if I read the question again, it is given that a pentagonal prism with side of base 30 mm, axis length 60 mm has one of its corners of base in the HP. So if it is given that it is resting on one of its corners, so we have to take the second condition, because in case of solids we would be tilting the solid onto the right hand side, so we have to check the condition on the right hand side of the solid. So if it is resting on one of its corners, we have to take the right hand side corner, and here the corner is point A. It means out of the two conditions here, the second condition is correct. Means by using this condition we are going to draw the pentagonal prism and then move ahead in the problem. Let us get started with the solution. Here we have an XY line and VPHP, that is vertical plane, horizontal plane. It is given that since the pentagonal prism is resting on its corners in HP, it means this prism is kept on the ground. HP is considered as a ground, and when we will be seeing that pentagonal prism from top, the pentagon, we are going to draw that now in the top view, because the pentagonal prism is resting in HP. If it would have been resting in VP, then in the front view we would have drawn the given pentagon. So now we are going to start with the top view first. Using this condition, I'll draw the pentagon, and its side of base is given as 30 mm. Marking 30 first. Then to draw the pentagon, the edges of the pentagon are inclined at an angle of 72 degree. It means here this edge is making an angle of 72 degree on one side. Similarly, this edge will also make an angle of 72 degree. In that way we are going to draw the pentagon. Measuring 72 from the other side as well. Then drawing the light projection here. Next, as the side is given as 30 mm, I'll measure that 30 mm into the compass. And mark it over here. Similarly here. Next, keeping the same distance, I'll keep a point here and draw an arc from the other side as well. So here I am getting that point and finally joining it. So this is the initial condition of the pentagonal prism. Now once I have drawn the initial condition, here I will give the notations to the pentagon. Then this is the top view of the pentagonal prism. After that, I am going to draw the front view, projecting the points upward. The height of the prism is given as 60 mm because the axis length is 60. So we have to take the height of the pentagonal prism as 60. Next, giving the same notations in the front view as well. Here point 1 and 2, they are coinciding. So in the front view, I'll give them as 1 dash, 2 dash. Similarly at the top, because we are going to get two pentagonal faces, one is at the bottom, other is at the top, since it is a pentagonal prism. Next 3 and 5, 3 dash, 5 dash, 3 dash, 5 dash, at last 4 dash, 4 dash. Now once I have drawn it light, next I'll have to make it dark. This is the initial condition. After this, I am going to mark the axis for this pentagonal prism. Here there is a 30 mm side of the pentagon, so I have to take half of this, which is 15, and then after taking this midpoint of the base, I'll connect it to the opposite corner. Similarly, I'll take half of this 30, join it to the opposite corner. Now wherever these two lines intersect, that is the axis of the pentagonal prism, will be projected in the front view. In the top view, this axis appears as a point because it is a line. When we are seeing from top, it will appear as a point, but when we are seeing it from front, it will appear as a line. That line needs to be projected in the front view. So here is the axis of the pentagonal prism. So this was the initial condition. After that, it is given in the question, a pentagonal prism with side of base 30 mm, axis length 60 mm has one of its corners of base in HP that we have drawn, such that the base of the prism makes an angle of 50 degree with HP. This is the second condition, that we have to make the base inclined at 50 degree with HP. It will be seen in VP. So here I'll make this base, which is corresponding to this pentagonal prism or the pentagonal face, which is 1 dash, 2 dash, 3 dash, 5 dash and 4 dash. It represents the base. Here it is in the form of a line. So this line needs to be made inclined at 50 degree with respect to HP, which will be seen in VP. Here I'll mark a point and take an angle of 50 degree. Next, I'll measure this base either from 4 dash to 1 dash or from 1 to 4, keeping this distance here, marking it on an inclined line which is at 50 degree. After this, since the base and the edges, that is the rectangular faces, they are perpendicular to each other. Once I have drawn this base, I'll take this point draw an angle at 90 degree. Similarly here, drawing a light line first. Next, measuring the height, which is the height of the axis, and that is equal to nothing but the height of the pentagonal prism, 60 mm. Marking 60 mm on this side, also on the other side. Next, I'll join these points. And giving the notations here. the corner on which the pentagonal prism is resting, that is corner 4. So it is tilted about that corner. It means here it is 4 dash and 4 dash. Next, this is 1 dash comma 2 dash. Then I'll take the distance from point 4 up to point 3. Drawing a light line. Here also I'll give the notation. It is 3 dash comma 5 dash, 3 dash, 5 dash. Next, I'll take the distance from point 4 up to the axis. Now, here I have made the pentagonal prism inclined and it is resting on one of its corners as mentioned in the question. I'll make it dark. Now, after I have completed the front view, the next thing is to draw the top view of this inclined pentagonal prism, and for that the observer is there at the top. Now, when we are looking at the pentagonal prism from the top, we have to draw those points first which are visible to us or which are close to us. If I see in this prism, here this top pentagonal face is closer to the observer compared to the bottom face. It means these points which are at the top will be projected first. First is point 1 dash 2 dash. Next, I'll project it from the top view as well. So here is point 1. Next, on this same line there will be point 2 will be projected from the top view. Point 2, then point 3 and 5, they are onto the same, they are at the same level, or we can say they will pass through the same line. So here I will project point 3 from the top view as well. After point 3, point 4. So point 4 will be projected from the top view as well. 0.4. Next 0.5, it is onto the same line as here, which I have projected from the front view. So 0.5 will be projected from top view. Next, since this pentagonal prism is closer to the observer, so it will be visible first. I'll connect these points first with the help of a light line, and then afterwards I'll make it dark. Then once I have projected the points of this prism which is there at the pentagon which is there at the top, now this bottom pentagon, so starting with 1 dash 2 dash at the bottom, point 1 and 2. Next again 3 and 5 will pass through the same line. Point 3 and 5. Then point 4 from the front view first. And then it is from the top view. So here I get 0.4. After this, how to connect the points? The outline of the drawing will never be hidden, so we have to connect the outline first. So here after this 5 and 5, here I'll connect 5 to 1 first with the help of a light line. Next 1 to 2 is already connected, then 2 to 3. So here I have drawn the outline. Now based on the visibility part, as we are looking from the top, this pentagonal face is visible, so it should be made dark first. So here I'll make this 1 2 3 4 5 as dark, drawing the dark lines here. Then as I have told, the outlines should be dark, so connecting the outlines. Then after connecting the outlines, when we are looking from top, here there is a rectangular face 1 dash 2 dash. It means for a pentagonal prism, it is having rectangular faces. That is, there are 5 rectangular faces. So here if the pentagonal prism is tilted, this rectangular face which is 1 dash 2 dash, that will be visible. So if I can explain here, that this is 0.1, here 0.2, and here also 0.1 and 2. So this rectangular face comes closer to the observer, so that is visible. So connecting 0.1 and 1, 0.2 with 0.2. So this is the visible portion of the pentagonal prism. Now, after reaching up till this stage, that is, this much is the visible portion of the pentagonal prism. Next, I have to draw the hidden portion. For that, if I see point 4 or 4 dash, when the observer is at the top, this point 4 is not visible, it means it is hidden. But the pentagonal prism is a continuous solid, means all the lines they are connected. So here from 4 to 1, first I will draw a light line, that is 4 to 5, and 4 to 3, drawing a light line. Next, after drawing these light lines, I have to connect them with the help of hidden line, that is the dashed lines from 4 to 5. And 3 to 4. Next, from point 4 to 4, since it is a continuous line, again that will also be hidden. Then, as we can see here, in case of this pentagonal prism, the rectangular faces which are visible, those are 1 5, and this is 1 5, this complete rectangular face is visible. Next, 1 2 and 1 2, that is visible. 2 3 and 2 3, this rectangular face is visible. Then two rectangular faces are going hidden, that is they are going behind the observer, so they are 4 5 and 4 5. And next 3 4 and 3 4, these two rectangular faces are going behind, so they are hidden. The remaining two rectangular faces are seen, so they are visible. Next, I'll mark the dimensions for it. It is 30 mm side and the axis height is 60. The base is inclined at an angle of 50 degree with HP given. So if base is making an angle of 50 degree, the axis will be making an angle of 40 degree. This also we can show it here, inclination of the axis, because the angle between the axis and the base, it is 90, they are perpendicular to each other. So if this is 50, that is the angle of the base, the angle of the axis will become 90 minus 50, that is 40 degree. And here I will mark the apex, give the axis as O, so in the front view it will be O dash, O dash. Similarly here that will be O dash, O dash. So once we have marked all the dimensions, we can say that the problem has been completed.